In question 4, we have to prove the identity sine cube upon sine minus 1 minus sine square upon 1 plus sine as minus tan square into 1 plus sine square. So we'll start this by first taking the LCM on the left hand side. So the LCM will be sine minus 1 and 1 plus sine. I'll be using S and T and C in place of sine, cos, and tan. So taking the LCM, this sine cube will multiply it by 1 plus sine, and this will be minus sine squared will multiply by sine minus 1. Expanding the bracket, we'll get sine cube plus sine to the power 4 minus sine squared plus, so this will become minus sine cube, and this will become a plus sine squared upon sine minus 1, and we can write this as sine plus 1. So sine cube and minus sine cube will cancel. In the numerator, now we have sine 4 plus sine squared. So we have sine 4 plus sine squared upon sine minus 1 sine plus 1. Now we can apply the basic identity from algebra, that is x minus y into x plus y is equals to x squared minus y squared. So we can write the denominator as sine squared minus 1. Taking sine squared common in the numerator, this will become sine squared plus 1 divided by sine squared minus 1. Now the identity that we had to prove was minus tan squared into 1 plus sine squared. So we already have sine squared plus 1 in the numerator. To get tan squared, this is sine squared. So in the denominator, we need a cos squared. Now we know that sine squared plus cos squared equals to 1, or cos squared is equals to 1 minus sine squared. But in the denominator, we have sine squared minus 1. To convert it to 1 minus sine squared, we'll have to multiply this by minus 1. So if you multiply this by minus 1, this will also multiply by minus 1. So this will become minus sine squared in the numerator plus 1, and this will become 1 minus sine squared. Now we can write this as minus sine squared upon cos squared into sine squared plus 1. So sine squared upon cos squared, now we can write it as minus tan squared theta bracket of sine squared theta plus 1, which was the identity that we had to prove. In part B, now it is asking us to solve the equation sine cube upon sine minus 1 minus sine square upon 1 plus sine equals to tan square into 1 minus sine squared. Now, the identity that we proved was minus tan squared into sine squared plus 1. So in place of this, we can write minus tan squared into sine squared plus 1 is equals to tan squared into 1 minus sine squared. So now opening up the brackets, we'll get minus tan squared into sine squared minus tan squared is equals to tan squared minus tan squared sine squared. Bringing the tan square on the negative tan square on the right hand side, this will become tan squared plus tan squared, and taking the minus tan squared sine squared on the left hand side, this will become plus tan squared sine squared. So minus tan squared plus tan squared sine squared will become a 0. So this will be 0 is equals to 2 tan squared, or we can say that tan squared theta will be equals to 0, as 0 divided by 2 will be a 0. And if we take the square root of 0, that will also be a 0. So tan theta will be equals to 0. Taking tan inverse of 0, one of the values of theta will be equals to 0. And the second value will be pi. Now to understand this, we know that tan is positive in the first and the third quadrant. So if we make an angle of 0 in the first quadrant, this angle will be 0. And if we make an angle of 0 in the third quadrant over here, so this angle will be equals to pi. So the two values of theta will be 0 and pi.